Okay, so following questions will be explained in this video: graphing tangent function and cotangent functions. So generally explaining how to graph tangent function. Given y equal to a tangent bx plus c, a will work that as vertical stretch or shrink, vertical stretch or shrink. B will work that as calculating period. So difference graphing tangent versus graphing sine or cosine is how to calculate period. So for tangent, period will be pi over absolute value of b. So graphing tangent function, how to calculate period is pi over absolute value of b. So you want to memorize this. Phase shift, which means vertical shift, will be minus c over b. Also, you need to memorize this. Of course, if there are plus d outside like this, that will be related to vertical shift, either moving everything up or down. So that will be general explanation, and let's try to graph tangent x. So value of b here will be 1. So b is equal to 1. So let's calculate period first. So period is gonna be pi over absolute value of b, which gives you pi over absolute value 1, which becomes just pi. So graph of tangent function would be, you start from the origin, you go one tick mark to the right, one tick mark to the left. From left to right, that will contain one period, one cycle of the graph. So length from here to here will be one period. So that's one period, which we calculate as a pi. So length from here to here is a pi, meaning length from here to here should be half of a period. So for one tick mark, you will have to calculate period divided by 2, which is this case pi over 2. So value here is going to be pi over 2, value here is going to be minus pi over 2, and that makes the entire period length to be pi. Graphing tangent is fairly simple. This is a vertical asymptote on this end, another vertical asymptote on this end, and your graph would be something similar to this. Of course, this is a periodic function, meaning if you go to the right, you will increment by pi over 2, 2 pi over 2, 3 pi over 2. Of course, 2 pi over 2 will be simplified to pi, but here will be another tangent graph like this. If you go to the left, it will be same repetition over and over. So as long as you graph this, then that will be it. So next graph I want to show you is, what if we have y equal to 3 tangent x? So if you compare with the previous tangent function, only difference is we have 3, which is related to the vertical stretch by 3. So everything else is the same, meaning we will have one tick mark to the right, one tick mark to the left. We will have vertical asymptote on both ends. Also period will be exactly same as pi. One tick mark we calculate as pi over 2. Nothing changes here. So if you look at the previous graph, it was looking like this. So all you have to change here is vertical shift. So I would say if you pick a point on a graph of tangent x, this point, x value of this point, the y value, not x value, y value, because it's a vertical stretch, y value of this point will be stretched by 3. So approximately that original graph has a point somewhere over here that will get stretched to up like by 3. So approximately the graph will be something like, yeah, this graph is not looking good, but you got the idea. It's gonna be a lot taller. So vertically stretching it, so all graph will be stretched. Overall shape will be very, very similar. Next graph I want to show you is y equal to tangent 3x. So if you look at this equation, b value here is 3, so that will change period. Period formula was pi over absolute value of b, so it becomes pi over 3, and that becomes a period. Well, one tick mark, we can get that as period divided by 2, which becomes pi third as a period, all over divided by 2 gives you pi sixth. So graphing tangent 3x will be very, very similar. Just put the vertical asymptotes on the both ends, and the length from left end to the right end is a period, which is 3 over pi. So half of that length will be pi sixth. So you go one tick mark to the right, pi sixth, one tick mark to the left, minus pi sixth, and overall shape of tangent 3x will be exactly the same as this. So it's another example of tangent function graph, but this time tangent 1/2 x. So value of b equal to 1/2, that will change period, which is pi over b, which becomes pi over 1 over 2. Pi divided by 1 over 2 is same as pi multiplied by the reciprocal, which is 2 pi, is period. 1 tick mark is period divided by 2, so 2 pi divided by 2 gives you pi. So graphing it should be fairly simple from here. You go 1 tick mark to the right, 1 tick, that's gonna be valuable. 1 tick mark will be pi. Here it will be minus pi. The graph would look like something like this, passing origin. Okay, we just graphed tangent 1/2 x. What if we have exactly same equation except we have minus in front of it? So this minus works out as reflection over x-axis. So if you look at this graph, it will be exactly same as this, but we do have reflection over x-axis. So we follow everything as it is. Graphing of that would be exactly same setting. You go what 1 tick mark to the right, 1 tick mark to the left, but when you graph it, make sure you reflect over x-axis. So this figure will be reflected here, that figure will be reflected here. So your overall graph should be something like this, and that would be graph of minus tangent 1/2 x. Okay, let's try graphing y equal to tangent parenthesis x minus pi over 2. So value of b here is equal to 1, meaning period calculation will be pi over absolute value of b, pi over absolute value of 1, which gives you pi. 1 tick mark calculation, period divided by 2, period was pi over 2, that's 1 tick mark. So since you have parenthesis x minus pi over pi over 2, this value is c equal to minus pi over 2. So that's related to phase shift. Phase shift is horizontal shift. So phase shift was minus c over b. So minus c value we recognize it as minus pi over 2 over b value was 1. So minus minus cancels out, dividing by 1 doesn't do much, pi over 2. So positive pi over 2 means we move right by pi over 2 as a phase shift. Okay, so let's graph this. So if nothing else, we could have put vertical asymptote here and here. 1 tick mark was pi over 2 minus pi over 2. We could have graphed vertical asymptote here, vertical asymptote here. Our graph would be something like here. That could have been our graph, but we are moving everything right by pi over 2. So our vertical asymptote used to be here and here, but we are moving that to right by pi over 2. So if you go 1 tick mark to the right, 1 pi over 2, this will be 2 pi over 2, which is equal to pi. So our vertical asymptote will move right by pi over 2. Also, this vertical asymptote will move right by pi over 2. So you have y-axis overlapping with the vertical asymptote here. And our graph should look like something like this. So we just shifted right by pi over 2. Okay, let's try to get graphing y equal to minus tangent 4x plus pi. So this minus is dealing with reflection over x-axis. Value of b is equal to 4, and we got c value here, c equal to 4. Let's deal with the period. Period equal to pi over absolute value of b, which gives you pi over absolute value of 4. Pi fourth is our period. 1 tick mark is half of period, so we got pi eighth. Phase shift is minus c over b, so we got the c value as minus c value as 4 over b. B was 4. No. Okay, c value was pi. So that was a mistake. C value was pi. So phase shift minus c over b, so it will be minus c, which is pi over b equal to 4. So phase shift is minus pi fourth, meaning we are gonna move left by pi fourth. Okay, so graph 1 tick mark was pi eighth, so we go right by pi eighth, left by pi eighth. If nothing else, we could have vertical asymptote here, vertical asymptote here, and since we have a minus, we would have reflection of the tangent x. The graph would be something like this. That would have been our graph. But we have a phase shift left by minus pi fourth. So if you think about it, minus pi fourth is 2 tick mark. 1 tick mark is pi eighth. So if you double pi eighth, that's same as minus pi fourth. Meaning everything will move to left by 2 tick mark, because 2 tick mark will be same as pi fourth. So if you think about it, our period was pi fourth, meaning same pattern will keep repeating every pi fourth, and we are shifting left by pi fourth. So if you move by multiple of a period, the graph will be exactly the same. Meaning if we move 1, 2, so you got minus 1 pi eighth, minus 2 pi eighth, minus 3 pi eighth, and that will be simplified to minus pi fourth. So we used to have vertical asymptote here and here, so that will be moved to the 1, 2 tick mark to the left. That will move to 1, 2 tick mark to the left. So if you do want to graph that portion, you can graph it here, vertical asymptote here, and you have to graph tangent graph with reflection over x-axis. So you will pass here, it's passing some over here, here. That would be a graph. What I was gonna say previously was, since we have period of pi fourth, there will be another one right here. So you could have just graphed that on the spot, or you graph it here, as long as you just graph one cycle. That's all I'm looking for. Okay, next one is graphing cotangent function. If you followed good tangent function, graphing cotangent function will be slight change from tangent, very similar. So only thing I have to add to graph y equal to cotangent x is following. As long as you know basic function, everything else is exactly the same. So calculating period of cotangent will be exactly the same. Period calculation will be exactly the same as tangent function. It will be pi divided by absolute value of b will give you period. So if you do here, since if b value is 1, you will end up with pi over absolute value 1, which is pi. 1 tick mark will be exactly the same, period divided by 2, which is pi half. Only thing is, the basic graph have vertical asymptote right here, another vertical asymptote right here, and your graph will start from here, and shape will be something like this. That will be basic graph of cotangent x. So you just need to memorize this shape and accordingly use it. Everything else will be exactly the same as tangent x graph. So let's practice this one. Graph y equal to 2 cotangent x. So that will be related to vertical stretch by 2. So if you look at this previous graph, it's identical, except you grab each point and vertically are stretching. So every other calculation will be exactly the same. Oh yeah, we forgot to put pi over 2 here. No, this should be pi over 2. That should be entire. That should be pi. So this length is a period. So we do use a period here. And there was a 1 tick mark, second tick mark. So it's the first tick mark of pi over 2, 2 pi over 2. That becomes pi. So coming back to here, 2 y equal to 2 cotangent x graph will be very similar to just cotangent x graph. So we got pi over 2 for first tick mark, 2 pi over 2, which becomes pi, and there's another vertical asymptote here. When you graph it, just make some stretch vertically. So I will have, again, this is a little tricky to graph. So graph will be something coming from here, something like that. Stretched vertically by 2. Okay. So last graph I prepared here is y equal to cotangent 1 over 2x. So value of b will be 1 over 2. So calculating period pi divided by value of b, which becomes pi divided by absolute value of 1 over 2, which becomes 2 pi. So one tick mark will be period divided by 2, which becomes a pi, because 2 pi over 2 becomes pi. That's pretty much all you need to figure out. So graph will be something like this. You go 1, 2 tick mark. Here's a vertical asymptote. Here's another vertical asymptote. And one tick mark was pi. Second tick mark was 2 pi. And graph will be something like this.